So when we're talking about any kind of national economic measure, we are, for the most part, talking about the nominal value of it. What do we mean when we're talking about the nominal value? The nominal value is just really the normal value. So it is an economic statistic that is actually announced at that time. So a nominal value is going to be not adjusted for inflation. So the best way to think about this is, when you are paid, that value on your paycheck is the nominal value, right? That's what you actually are getting paid. Now, if you want to compare how much you're getting paid now to how much you might have got paid 10 years ago, well, just comparing the amount on your paychecks is not going to give you the most accurate comparison. Why? Because prices over time increase. And so is it that you're getting paid more money, or is it just the fact that your pay kept up with the general rise in the price level, right? So in order to figure that out, we would want to convert to your real values. So a real value is an economic statistic after it has been adjusted for inflation. In general, this one is the more important one. And again, that's because when we're looking at the nominal, we are looking at not just the increase in the amount of stuff, but we're also looking at the increase in the price level. And so how do we do this? Well, we use something called a GDP deflator. A GDP deflator is a price index that measures the average prices of all goods and services included in the economy. There is another type of price index that the book doesn't talk about, but you'll see it commonly referred to if you look at other books or other videos or whatever, right? So just a quick little deviation here. We do have another price index called the Consumer Price Index, which is known as the CPI. And this is a price index measuring the average prices for a typical basket of goods and services consumed by a household. So the GDP deflator is all the goods and services, right? All the goods and services included in an economy. Whereas the consumer price index is just a basket. It's tracking the prices for a basket of goods and services, right? So they literally call households and they say, how many loaves of bread did you buy this week? How many, things of milk did you buy? How many cans of beans? How many pounds of beef? That kind of stuff, right? And then they calculate what the typical average consumption bundle is, basket is, and they track that price. So how do we use the GDP deflator in order to calculate real GDP? Great question. Let's go ahead and dig right into it. So calculating real GDP. So our formula for calculating real GDP is that we are going to take whatever the nominal GDP is, and we are going to divide it by whatever the price index is, divide that by 100. And our price index for this particular class is going to be always synonymous with the GDP deflator. So the best way for us to do this is with an example. So we are given some values in the book. We are told that in the year 1960, the nominal GDP was $543.3 billion. We were told that the GDP deflator, which has a base year of 2005, so that means that 2005 is going to equal 100. So we're told that the GDP deflator for 1960 is 19.0. And so how do we get to our real GDP? Which, since it's a real GDP instead of a nominal GDP, we need to say what it's in, and we would say this is a real GDP in 2005 dollars. And so how do we get there? We are going to do the calculations together. So we're going to take the nominal GDP, 543.3. We're going to divide it by the price index, 19. Divide that by 100. This ends up giving us 2,859.5 billion, or 2.8 trillion US dollars. And for the most part, because of the fact that prices increase, and prices have increased in the United States at least every single year except for a short little bit of the Great Depression there, right? Because of the fact that prices increase over time, when we pull some value from the past, right, we're pulling this nominal value from 1960, it should get bigger, which it did, right? It's, almost 6 times the size that it was before. So when we pull something from the past to the present, or to just somewhere further closer to the present, right, 2005, if we pull something in the past forward, we expect the value to increase. Now let's go ahead and do 2010. So 2010, we have a nominal GDP of $14,958 billion. We have a GDP deflator that is 110.0. And so again, in order to do our calculations, we're going to take this and put it in the numerator, 14,958.3. We're going to divide it by whatever that GDP deflator is, whatever that price index is, divided by 100. And this is going to give me 13,598.5 billion, or 13.6 if we're rounding trillion dollars. So what's happening here? What's happening to the number when we find the real value of it compared to the nominal value of it? Is it getting bigger or smaller? It's getting smaller this time, right? So why is it getting smaller? It's getting smaller because we're bringing something from, if we think about this as a number line, 1960, 2010, 2005, right? So the first one we had, we brought this forward. So we would expect it to be larger. Now we're bringing it backwards, so we would expect it to be smaller. So this is just a general kind of rule to check yourself to make sure that you're doing it right, that you're not multiplying when you should be dividing. Now, those of you that read, you know the answer to this, but what would the GDP be? Or sorry, so if we were told that the nominal GDP for 2005 is 13 trillion and 95.4 billion dollars, what would the real GDP be for 2005? For a get out of jail free card. So 2005 is our base year. Here, let's do it together. So we're going to take this value, 13,095.4. The GDP deflator for this particular year is 100. So we're going to divide this whole thing by 100 divided by 100. 100 divided by 100 is just 1, right? So the GDP, the real GDP in the base year, right? This is our base year. The real GDP is always going to exactly equal the nominal GDP whenever we calculate it for that base year. Because essentially that price index just becomes 100 divided by 100 just becomes 1. Does that make sense to everyone? Okay, sweet. So the book has some actual data behind it, but just for the sake of brevity, I just want to kind of just talk about this real quick, that because of this, we end up getting a nominal GDP that looks something like this. And we end up getting a real GDP that's always higher than the nominal GDP all the way up until some point, and then it's always lower. And what is that point where it crosses? The base year. Very good, 2005. Oh, I backwards that. And this is billions of dollars. And this is time. Always got to label our axes, right?